pondering two ideas at the same time, which is about time and pondering. Time involves causality, not in the trivial sense of cause and effect and cheesy notions of that, but causality in the cosmological, quantum, physical sense that things, particles, bits, molecules, people, planets, fields, waves interact. They actually relate. They affect each other. This in physics terms, philosophic terms, we call causality. And the great insight derived by Einstein and his cohorts was the idea of relativity, frames of reference in which to interpret events, causality. And that E equals mc squared, the idea of a c, the speed of light, a speed of wave, a speed limit of propagation of information, the speed of causality. Essential in, I don't really know where I started that sentence. I'm lost in the causality of that sentence. But the idea, the basic idea, is that there's only so quickly two things in the universe, two parts of space-time communicate. There's only so quickly that can happen. In other words, no such thing as instantaneous speed to which things can affect each other or interact. Particles can move, or so it would seem. Physics and mathematics, Lorentz transformations, and Minkowski space-time, and all that fancy stuff. The basic idea, though, is that when you're dealing with causality, you basically have to be able to translate, transcode, transform Lorentz transformations between reference frames. There is no universal reference frame in which everything is taking place. That's not a provable statement, as we know yet, because there may actually be a universal reference frame, but it would be impossible for us as observers within the universal reference frame to make any meaningful claims about it, perhaps. But the idea is that every observer in the universe, whether it's a person or another particle or a telescope or a computer, has a reference frame in space-time in which it's operating, and to claim anything in relation to anything else, you have to translate between these reference frames. And you can only do so at a maximum speed, the speed of causality, the speed of electromagnetic waves, the speed of light. Light is a stand-in for information. Causality is a stand-in for information. Information is that difference between things in the universe. Difference being position in space and time, space-time. When you bubble up all those differences in space-time, literally a point, the smallest thing you could imagine in space-time, a point, a massless, zero-dimension, and however you want to think about dimensions, frankly, the smallest possible idea of existence, a bit, if you will, its position in space-time relative to any other bit's position in space-time as well as its own position, a loop unto itself, is the bit of information. This is heady stuff that, in my estimation, it's heady to me. May not be heady to you, may be nonsense to you. May have no reference to your reference, which is quite the point about my second topic, which is pondering. There is no difference functionally, physically, between talking about particles' difference in space-time or our two different persons' understanding of the world, our cognition, our coherence, our consciousness of states of the world, our awareness of our reference frames, our usage of computers, our one computer to the other computer's understanding. Those can be contemplated as reference frames in a broad sense, and that the maximum speed at which you can translate between two computers, practical terms or Newtonian terms of the scale of human cognition, perhaps. Obviously, the quote speed of information, the speed of knowledge, the speed of translating between reference frames, the speed of noticing difference, of taking account of how things are different or how they're the same, which is really the inverse, but is effectively measuring the same information, is of much lower speed. In effect, it's a sum, in some sense, an integral maybe, something, a grander sense of sum, but nonetheless, a sum of all those causal elements that need to notice the difference between things. That is, let's just take a simplified idea, your brain. For my brain to recognize that your brain has a different understanding of some topic we're talking about, some subject we're looking at, some object we're considering. Our brains have to, there's a lot of billions, trillions of neurons that all have to notice something about some other neuron. Patterns have to come together, our various bodily apparatuses kind of have to be affected, related to the reference frames that we're considering, both the other person as well as the third reference frame we're looking at, a clock, a printout from a computer, whatever. We're actually talking about trying to come to a common understanding. And so when you think about a speed of causality, you would have to sum over all those individual things that make up the pattern that we would be considered the subject that we're looking at. And in fact, even when you're doing physics, if you want to tie our understanding of physics, you have to think about the same thing, which is the speed at which an experiment can be run regarding the speed of light. Its total speed is much, much lower than the speed of light, because inevitably you have many different reference frames that all need to be affected and accounted for. So let's just consider the classic experiment of measuring the speed of light on Earth, where you have these measuring devices separated by kilometers, and they're really taking light around and affecting whatever. And so you've got mirrors and lasers and all sorts of things, and all of those things have their own reference frame in which you have to translate between. And those the causal effects between all those things all take up time, meaning they do not happen instantaneously. And so the actual noticing of the speed of light, this is a critical point. not just the actual effect, the non-detected effect of light, information, causality, moving between objects, and that's even the wrong words, forget moving, information exchanged, information contained, information shared between 2 points on the Earth being interpreted through measuring devices so that we can verify that the speed of light actually is what it is, takes quite a bit of human time, human scale, noticing of time passing, noticing of clock hands moving to happen. Okay, so I think that's fairly obvious at this point. I've killed that. Now, when we actually do measure the speed of light and we shoot an electron from one place to the other, just a single electron, so a single particle, a single waveform, a single amplitude of a waveform, the smallest thing that you could move from here to there. What actually happens? Does it happen instantaneously, and it's actually the noticing where we actually have a speed limit? Is observation from cause? Is it really the observation where the speed limit is, and the actual relationship, the actual sharing of information is instantaneous? So, as an example, consider two entangled quantum particles. Is that entanglement actually instantaneous, meaning that it is ever present? There is no movement required, it's just present. And it's only when we are attempting to measure things, to notice that things are entangled, to definitively prove that they're entangled, in which a speed of causality, a speed of information, a speed of relation, a speed of sharing, a speed of entanglement is actually in place. It appears that this is likely the case, that it is the summation over patterned patterns which come together in the form of measurement instruments, molecules, people, birds, chronometers, gravitrons, all these different things that detect the different fields and effects and particles. Only when you have patterns that need to notice that other patterns are related does, quote, time pop into existence. Time really is a stand-in. In a way, it's a variable notion, it's a term, it's a concept for causality. It's a stand-in. It's a common sense way of acknowledging difference. Noticing that things are different in space-time. That they occupy different places in space-time, different extents. The extent in space-time, that space-time itself is different. And a way to contemplate that slightly differently is that to a wave, to a particle, a massless particle moving at the speed of causality, the speed of light, there is no time. It does not notice because it is traveling. Beam of sunlight because it is traveling at the speed of light. It has no sense of time. There is no sense of cause and effect. It leaves the sun and arrives in your eye at exactly the same time. Because there is no causality to light. It is the medium of causality. Another way to think about it, a bit has no experience. A photon has no experience. Now, you might want to reinterpret this and cast some skeptical questions on it. Talk about, well, we can change the directions of photons, bend them, gravity bends them. Yes. In fact, that's true. Space-time itself can misdirect, redirect light. Black holes do all sorts of strange things with time and space. They literally change the very fabric of existence, of causality, of information. Now, the question that emerges from that is, at what point do things cease to be information? At which point the difference no longer noticed? At which point, at what topological concept in terms of space-time is difference making difference, the relationship, awareness, information detection no longer possible, and it becomes a nonsensical concept, time ceases to exist. I think what we're finding is that black holes are a reasonable example of there are ways to bend information to the point at which it is no longer information. A singularity in the physics terms. And then of course we have all sorts of interesting results in things like Hawking radiation and ideas of information conservation, which gets into a whole bunch of different things, but these concepts fundamentally do not contradict the idea that observation seems to be, information seems to be the critical notion. The idea that inside of a black hole there is no longer coherent information. There's no longer meaningful information. It literally is nonsensical. There is no space-time. There is no causality inside a black hole. Which a different way to think about it is, or a different kind of phenomenon to think about is, in a very entropic system, one that is functionally random, a high-energy gas or however you want to think about it, a random number generator that's perfect, a perfect random number generator. There's no information content in that either. So everything's perfectly random. There is no sense of cause. There is no sense of effect. Everything that is going to happen in the random number generator is perfect. It is random. There is no way to make a coherent statement. Literally, there is no observation to be made about a random number generator other than here's a random number generator. Just like there is no coherent observation to make about the center of a black hole, whatever that may be. There is no there. There's nothing to be said. You cannot even find the center of a black hole. You're sort of stuck to say there is a black hole, and that's the limit of what you can say about it. Now, a third thing to tie all these ideas together, if you're still tracking, there is an emergent state when you're translating reference frames. Go back to everything I just discussed about translating reference frames and doing Lorentz transformations and using special relativity and all this crap. You don't even have to do that fancy stuff. You can just think about computer programs that are somewhat interesting. They do non-trivial things. They have slight complexity in this. I don't mean that to mean that big, long, scary programs like Word or something like that. Just mean very trivial programs. But they effectively do non-linear things, or things that are slightly more challenging than like print the number 1. No matter what you do, just print 1. Anyway, get in your head that there are programs that can do slightly interesting things. You get enough of these trying to interact and interpret each other's results, and you effectively emerge to this idea of a completely entropic state, or like a black hole where information ceases to exist. Meaning there is no meaningful thing you can say about what's going on. These systems, the things that are emerging, the behaviors that are emerging, do not have any causal effect on each other that you can make sense of. Meaning the cause and the effect are separated. Effectively, there is no information transfer. Which, if you take an example, if this helps. We have these problems in physics all the time where there's only so many reference frames that we can keep track of at any given time in the universe, and maybe just recently, the Space Agency, there was a Milky Way, air quotes, which is tracking some subset stars is tracking, dotted close to totality. And what we mean by tracking is we get some sense of where they're located in space-time relative to each other. We have some sense of brightness, but then when you want to go deeper to understand much else about these stars, our ability to the extent to which we can do so for the majority of those stars diminishes greatly. And we actually have much lower fidelity in terms of saying something useful, having information on these stars, these 1.7 billion stars, all of which are the size of the sun or bigger. So these are just unimaginably big things that we have trouble saying anything meaningful about. That should give you some sense of the impossibility of grokking much about the universe in its totality. Any sense of a universal reference frame, vaguely close to that. And all three of these things I've talked about, highly entropic states or perfectly entropic states, functional randomness, complete randomness, complete noise, black holes and singularities, as well as emergent challenges, complexity, calculating, translating, extracting pattern, extracting information, and noticing differences from these things becomes exceedingly impossible. Computational capabilities, causally irreducible, speed of causality, effectively magical. Information cannot travel any faster. These three things are all the same. Fortunately or unfortunately for humans, our ability to understand things has a much lower speed limit, has a much lower threshold. It doesn't mean we can't continue to learn more and more about things and translate them into reference frames, but it does mean we cannot compute everything. In fact, the space of things that we cannot figure out, that we will not notice, is exceedingly infinite, which But it also doesn't suggest that we can't build up meaningful theories that effectively might give us a grand, unified sense of how things might be working. I think we have a pretty good indication of these things. What it means is you can have a theory, you can have a program, you can literally have a program description for how everything in the universe might work, but you cannot know all its effects. And so this leads to an epistemological situation. It's sort of a paradox. You could effectively have a program for the universe, but not have total knowledge. So even if you want to have a simpler idea, you can definitively, and it would be very trivial to demo this, you could effectively sit down at your computer, write a little program, and it have a very clear written form, and you would never, given an infinite amount of time, know all the possible things that program would do. So in effect, you're stuck in this strange epistemological situation where you can have a grandmaster plan and never be able to enumerate all the effects, causes, consequences, relationships of that plan executed. I actually think that while that sounds like a paradox, and it certainly is in a very common sense way, it's actually the only way in which existence, or at least existence where there is awareness, where things can relate to each other, where the twist they can exchange information, where they can notice, where they can be in relation to each other, is the only possibility for that. And I think it's the consequence of what was discussed in terms of the black holes and the entropy, the emergent complexity, which is causing the effects of relationships need to be infinite. It's a collection of finite things. This gets very strange. It's very number set theory kind of thinking that I'm doing here, which is a infinite set of finite things is the only way in which you could contemplate, generate a noticeable infinity anyway. That if you had a finite program description, a finite mathematics, a finite physics, that also could comprehend everything that would emerge from that physics beforehand, you would notice nothing. You would effectively be like a photon. That in the fact that everything would be revealed means it would be revealed instantaneously and therefore would not exist to you. It would not be aware. You would not be able to do anything with it. Contemplation itself, awareness, reference framing, translating between reference frames are all required for there to be anything to notice at all. This is very circular. This is very recursive. Without doing some of the math. But even if you're doing some of the math, it becomes very recursive in a sense. You're left at the end of this, like I am, kind of stuck, floating around. I don't know where the beginning is. I don't know where the end is. I don't know if I'm in some weird black hole of recursive logic. And the answer is yes. The answer is most definitely yes. Does it mean I've figured it all out? No. Anybody's figured it all out? No. Anybody who claims that, I challenge them to try and build a rocket on Mars with a person in it, which I know for a fact they can't do, or would be doing. As It's like, oh, well, we have the physics to know how to do it. Well, yes and no. Theoretically, we know how to take objects and shoot them at distant objects, but we don't know how to do it reliably. We don't know how to do it cost effectively. We don't know how to make sure that when things land there, they don't have to recover them. Hopefully you're able to turn them on and they last for a little while. I mean, all of those things to me have to be considered as part of the reference frame translation you have to do. That is the never-ending enumeration of all the causes, all the effects, these things you can use interchangeably, all the consequences of things relating to each other. There will be no end to that, because often, once we've gotten to the next level of ability in translating between reference frames, the references, however you want to think about it, have moved on and been altered, or our awareness of them have been altered, and you have to keep adjusting. Even if you got to the end of this video, it took, 30 minutes of translation from my head to a voice recording to you. And I don't know if I could do it any faster, and I don't even know if I've done anything at all. Which is probably a good way to end this, if you're still listening.